2. Is that right?
Yeah.
Okay. Yeah, thank you. So we also get, but this time we get positive 0.5, right?
Mhm.
So basically, kind of skirting around 4. Okay, well, I mean, we'll actually try to, we'll draw a picture of, we'll get a graph up here of our function. We want to narrow in around 4, so I might graph it from 1 to 6. And let's see, we were getting things like 2 and 3. So I don't know, actually that might, yeah, that's probably a decent enough window. Okay, so there's our graph, and we are sort of dancing around the point 4. I'm sorry, I keep. Alright, so there is where 4 seconds is located, right here, okay? So, between 3 seconds and 4 seconds, my average slope was down. Well, I think I'm gonna find the actual tangent line, or sorry, not, it won't be tangent because it was going through 2 points. The line that goes from 3 to 4, and then I might find a line that goes from 4 to 4.5, and we'll kind of graph both of those lines. So, this was the first one we found, that was between 3 and 4, so my slope is -1. It goes through the point 4, 2. So when y is 2, x is supposed to be 4, so my y-intercept value would be 6, right? So y equals -x plus 6 is, now we call this a secant line when it goes, a line through 2 points of a graph is called a secant line. So I'm going to graph -x plus 6. And you can kind of see it slicing through there. And then the other line, I'll do the last one here, the 4.5 to 4. We know that it still is going through the point 4, 2, so y is 2 when x is 4. So b would be 0, right? Because half of 4 is 2. So y equals 0.5x is the secant line from the point 4, 2 to 4.5 to 2.25. Alright, so again, I blew the picture up pretty much, and so our things are a little extreme, but the red line was trying to approximate the slope at 4. The black line was also trying to approximate the slope at 4. Just kind of looking at the picture, if we really drew a line that was tangent at that particular point, this peak line looks like it's actually tangent to the curve at that point, and what's the slope of the peak line? 0. Okay? So, part B of the question says use the dy dx program on your calculator, so I'm going to introduce you to that program if you don't already know it. But it's a program that, for the most part, is giving you instantaneous velocity at a point. How it's programmed, though, it's programmed to kind of do what we were doing. That it finds slopes until the slopes get so close together that they're accurate out to the 9th decimal place, and then it stops. Okay, so the program on your calculator is actually doing this, like it's finding a slope and finding a slope and finding a slope until, you know, until slope n is within 9 decimal places of slope n minus 1, and then it stops. A few days from now, we're going to learn some rules where kind of algebraically we can actually find the instantaneous slopes for certain functions. I just want you to know your calculator is actually not programmed with those formulas. Instead, it's doing this. So every once in a while, it might choke on running if there's something goofy about your function, because it's not necessarily plugging something in. It doesn't happen very often, but I always find it's better to understand what a program is really doing, because that way, if it ever does mess up, one, you might recognize it messed up, or two, you might understand why it messed up. Alright, so let me delete these lines, or turn them off. If you're, again, I really recommended, I would highly recommend people taking the graphing calculator class prior to taking this class, but I know by now it's too late. But you can turn functions off and on by moving with the arrows on top of the equal signs, and then you hit enter, and if it's on, it'll turn it off. If it was off, it'll turn it on. So so without deleting these, I've turned them off. So it should only graph the function. So that's something that you might find helpful. Second thing, this next program I'm going to introduce to you is going to be our friend. It's going to be a way for us to check our answer when we're doing bigger, messier things. So you will find that you end up using it a lot. If you hit the second and then the trace button,